to be reading and answering the questions for April 24th's AMI work for the topic of science. This passage is titled When You Are in Motion. So, as you guessed it, we're going to be talking about motion. Let's go ahead and read our passage. Did you know that everything, including you, is affected by the forces of inertia and momentum? Inertia is the tendency of unmoving objects to remain at rest. We have a vocab word here in its definition, so I'm going to go ahead and highlight this. It also applies to the tendency of moving objects to remain moving in a straight line. A car remains at rest until it receives the power to get moving. A bicycle needs to be pedaled. If you are riding a bicycle or driving a car and you slam on the brakes, you will continue moving in a straight line unless a physical object stops you. This is why seatbelts are so important in a car. Just because the car stops suddenly doesn't mean you do. You need a seatbelt to keep you from continuing forward. Momentum is an object's tendency to continue moving once it is in motion. The momentum of a vehicle is measured by multiplying the mass of the vehicle times the velocity, speed it is moving. If a car's mass is 2,000 pounds and it is moving at 20 miles per hour north, then its momentum is 40,000 pounds per hour north. That's 20,000 times 20. Velocity and momentum include speed and direction. This is why car crashes can involve so much damage. They weigh a lot, and they can travel at a high velocity. A related concept is called the conservation of momentum. Another vocab term. Imagine two balls, each having the same mass. One of the balls is rolling, and it hits the other ball, which is not rolling. The momentum of the first ball is transferred to the second ball. The first ball stops, and the second ball moves. You can think about this like if you were playing pool. This ball is just whizzing by, and he goes and he slams into this one. So our first one stops, but now our second one goes forward. The momentum is transferred from our first ball into our second. Let's move on to our questions. What did we learn? Number 1, what is the term for an object's tendency to continue moving once it is in motion? I already have highlighted our vocab terms. Yay. So let's look. Tendency to continue moving. Momentum is an object's tendency to continue moving once it is in motion. So, bing, bing, boom. We know our answer for number 1 is B. What is the tendency of an unmoving object to remain at rest called? Haha. Highlighting those vocab words pay off. Inertia is the tendency of unmoving objects to remain at rest. Our answer is inertia. How is momentum computed? So how do we solve for momentum? A, multiplying the mass times inertia. B, multiplying the mass times the velocity. C, multiplying the inertia times the momentum. Or D, all of the above. Whew. Okay, we need to refer back to our passage. So, the momentum of a vehicle is measured by multiplying the mass of the vehicle times the velocity. So, our big M, momentum, is calculated by our mass times velocity. Now, A, did we talk about inertia? No, A is incorrect. B, mass times velocity? Ding, ding, ding. But let's check the rest because we have this all of the above stuff going on. C, multiplying the inertia times the momentum. Well, no, we are looking for the momentum. C is incorrect. And since C and A we know are wrong, it can't be D. That means our answer is most definitely, without a doubt, B. Okay, let's think about this. Imagine a red marble is sitting in the groove of a ruler. That is not red. You know what? We need to get fancy up in here. We need red. Here's our red marble. And he's just chilling out in this little groove. Now, the red marble is not moving. If a blue marble... So our blue marble is rolled in this groove. And it hits our red marble. what's going to happen to the blue marble? Remember what they talked about in the diagram I drew up here with our one rolling ball hitting one that is stopped. The one that's moving is going to stop moving because his momentum is transferring and going to the unmoving object. In our case, our blue marble is going to stop because all of its momentum is being transferred to our red marble. The only option that has that is C. 5. Why is it very dangerous to ride in a car without a seatbelt, even at slow speed? Explain your answer in terms of inertia and momentum. This is an open response, so we need to make sure we are using CSRQ, complete sentence, restate the question. We also need to use terms inertia and momentum. This is going to take me a little while to write it out. Whew. Goodness, hang with me. So, first we need to restate the question. It is very dangerous to ride in a car I think my pencil's a little too bold for this. Car. I'm going to shorten without a seatbelt. Due to our momentum. While the brakes on a car stops its momentum, and therefore increases its inertia, because inertia is the tendency to want to stay stopped. Unless something stops us, we continue moving in a straight line. Right out the windshield. That might be a little gruesome to think about, but sadly, that is the case. Your seatbelt is incredibly important. If you're a driver or in the passenger front seat of the car and you're not wearing your seatbelt, your body is going to keep moving. You are still moving at a velocity of like 60 miles per hour, and then all of a sudden the car stops, but you don't. You're going to keep moving unless something stops you, and that something is your seatbelt. So let's check. Did I use complete sentences? Yup. Did I restate the question? Oh yeah. There we have it. That is April 24th science work.